hey, sorry about that. Math brought to you by Diet Mountain Dew. Okay, today we're going to do a lesson on inequalities involving absolute value. If you remember, we've done something kind of like this before. We've done equations. And the little trick, let's just do an equation with absolute value. If you remember, the absolute value symbol, it kind of like disguises, yeah, it does. It disguises kind of what's inside. Because once you take the absolute value of something, it always is going to make it positive. So do you see that x could be 4? Take the absolute value of 4 and it equals 4. But it also could be negative 4, because you take the absolute value of negative 4 and it also equals 4. So x there could be the positive thing, or it could be the opposite of that. The same thing is you're going to have to keep that in mind as we do inequalities. So let's make this an inequality. So there's going to be two cases here. It could be just plain old x, case 1. And so that would mean x is greater than or equal to 4. But case 2, this thing could be the opposite of that. It could be the opposite of x is greater than or equal to 4. If we make this a slight bit more complicated, which is probably a better example, let's do something just a tiny bit more. So, like absolute value of x plus 1. So, it could be x plus 1 is greater than or equal to 4, or it could be the opposite of x plus 1 is greater than or equal to 4. You're going to solve both of these, and you're going to graph both of these. So this one, simply take away the 1, move to that side, x is greater than or equal to 3. So we're going to take care of that one. This is like negative 1 times that. Let's get rid of the negative 1. Divide. Remember, when I divide, I've got to flip the sign. So it's going to be x plus 1. Now it's going to be less than or equal to negative 4. Take away the 1. X is less than or equal to negative 5. So that's really the trick. If you can remember that the absolute value symbol, it could be disguising just what it is, or it could be disguising the opposite of what it is, and then you're going to have to solve both cases. So then if we were going to graph this, of course, you would put it in here. Now, at this point, I have to tell you there's another little trick, and I hate that there's so many little things to think about with this, but you have to know whether it's and or. And it's not the same for everything. So here's the trick. If the original equation starts off as greater than or equal to, I just remember it greater sounds almost like or. If it starts off as less than, at the end of it and sounds almost like and. I know that this is greater than, I know there's a than, yes, I got that. But in any way, just to kind of remind yourself, greater sounds like or, less than sounds like and. So if your original problem starts off as greater, it's going to be or. If it starts off as less than, it's going to be and. So now we know how to graph it. Since this started off as greater than, it's going to be or. So we're going to do both things. So we would make our graph. X is greater than or equal to 3. So we go to 3, put a closed circle because greater than or equal to. And then it's going to be everything to the right is shaded in. The next thing is x is less than or equal to negative 5. Go to negative 5. Put a closed circle. Everything to the left is shaded in. And we got it. Okay? So if this started off as less than, we would only do the place where they overlap. And in this case, actually, it would be a different problem. Okay? All right. Hope you get that. And I'm out.